I'm Jamie Chasteen. I'm Senior Product Manager for Cold Chain Technologies. We're here at IQPC in Boston, Massachusetts, and I'm going to be talking about the industry's first solid PCM, which we're calling Koolit Advanced PCM Gel. So some people might know this as a shaped stable PCM. So I'm going to give a little bit of background on the history of PCMs, and then I'm going to talk about the benefits of gel PCM specifically. So I think some of us have been in the industry for a long time. You think back maybe a decade or so ago is when PCM systems started hitting the market. Those early systems were typically VIP PCM based systems, small parcel for the most part, and they really drove this need for return reuse markets in order to make them financially sustainable. But in the years since then, a number of manufacturers like ourselves have been designing and manufacturing systems where we combine PCM with other insulating technologies such as EPS in our GTS Excel line or polyurethane in our GTS Extreme line. And as we've done that, we've been able to apply PCM systems to every segment of life sciences, so small parcel, bulk solutions, domestic, international, and the result has been for the industry that you're looking at systems that perform better, are smaller, are lighter, and can actually be less expensive to procure than comparing them to the all-water-based predecessors that came before them. But regardless of which PCM you've been using, until now, PCMs have all had one thing in common, and that's that they've been liquid when thawed. So you can see this is a traditional PCM. Obviously there's a liquid inside of this bottle, and there's three main benefits that you get out of a gelled PCM, or limitations that we've had when designing with liquid PCMs. I'm going to talk about. I'll talk about thermal performance, I'll talk about physical performance, and I'm going to talk about flexibility of the product design and how that pertains to modular product platforms. So first thing we'll talk about thermal performance. This is a bottle. This is just our typical production bottle. It might be tough to see, but there's a head space at the top of that bottle. You cannot fill a bottle to 100% of its volume with liquid PCM. So what that means is if you put this bottle on all four sides, all the way around your product load, that top edge all the way around my product is going to have a lack of coverage of phase change material. So how will we compensate for that? Well, what we've done is we've used a little bit more PCM, or we've used more insulation in order to get the performance that we need. The other problem that you have with bottles is the plastic themselves. It can be a little bit costly and it can add some weight to the system, but the plastic itself is thermally inefficient for our shipping systems. Again, how do we overcome that? Well, we use more PCM, we use more insulation in order to hit that performance target that we're going for. I'm going to show you the PCM gel now, and I'll pass this around, you guys can handle it, but this is thawed. This is a fully thawed material. It's solid. So I can now have this sitting on the sides of my payload, and if I want to get coverage, if I need it in those top edges, I can get coverage in those top edges. It's going to allow me to design a system that's more thermally efficient. I don't have to use as much PCM. I don't have to use as much insulation to hit those same performance targets. I'm going to compare it to a liquid mat. It's another method of packaging PCM you might be familiar with. This is a liquid mat. You can see it's falling with gravity, right? So we have more PCM at the bottom of the mat here than we do at the top. So I don't have uniform thermal coverage over that payload. Again, what does that mean? How have we compensated for that? Well, we've added more PCM to the system, we've added more insulation. Of course, when we're working with a solid PCM, I can make this thinner. I can get coverage exactly where I need it and only where I need it. If I don't need coverage in the center of my payload, but I need to have coverage on the edges and in my corners, I can do that. So it's going to allow us to design systems that thermally perform better, are smaller, are lighter, and have a lower total cost of ownership. The second thing I'll talk about is performance. Regardless of which system of packaging a PCM you might be familiar with, the distribution environment can be tough, and this is particularly important when we start thinking about return reuse. And if you damage a PCM, whether it's a bottle, a brick, a mat, you could have PCM escape that packaging. I think this might be the most obvious benefit of a gel PCM. I cut this open just before this demo. This is thawed. This is a refrigerated PCM that's been sitting at room temperature for a couple of days. This is a solid piece of material. even if you intentionally damage the packaging, you cannot possibly have any leaks. And so this provides an awful lot of peace of mind to our clients. So the last thing I'm going to talk about is the flexibility of the packaging design and how that lends itself to modular product family. So again, PCM bottle, you're gonna have 6 sides of coverage. This is one of these nice fancy bottles with our mitered edges. We make it, the same bottle fits together nice around a cubic payload. Well, that's great, but what if I wanna ship 4, 5, or 6 different sizes of small parcel system? I have 2 options now when I'm using a bottle. One option is I tool up, I purchase, and, or I should say you purchase, and you condition several different sizes of bottle, a unique bottle size for every different size of shipper that you have. That obviously has its disadvantages. The other option is I get away from having one of these fancy bottles with all these edges. I just pick the lowest common denominator, the smallest face of my cubic payload, and as I get bigger and bigger sizes, I'm just going to continue to double up and use more and more bottles. But as I get to my larger shippers, I may have 25, 35, 40 different bottles that I'm stacking into that shipper. One of the nice things about this flexible design is that I can now wrap over payloads, or wrap around my payloads, wrap around corners. So with this type of design, I can have 3 refrigerant touches to get on all 6 sides of my payload, whereas it would take 6 touches of refrigerants to get on all 6 sides of a payload with a bottle. So I can still get modularity, purchase 1 refrigerant SKU, use that 1 size of refrigerant SKU across all my sizes of small parcel system, but reduce my touches when compared to a rigid bottle, and cut those touches in half. So again, improve thermal performance, improve physical performance, and being able to apply this in a modular product family. What we've done is we're qualifying all of our existing PCM systems with gel PCM. All of that has been underway and is being done now. And what that's doing is that's improving the duration and performance of our systems. We're getting better performance with all of today's existing components by simply swapping out an interchangeable gel PCM for a liquid PCM. But moving forward, because of all those thermal benefits that we get, we're able to design smaller, lighter, lower cost, better performing systems overall. So with that, I'll take any questions if anybody has them. I did say I would pass around one of the gel PCMs. I did not do that, my apologies. I'll just pass this one around. Thanks. You can handle that.
What's the cost differential?
Well, the beauty of it is when we're designing systems overall is that the system cost can actually go down because we're looking at making smaller, lighter systems, correct. So we have multiple temperature ranges of gel PCM for both refrigerated and controlled room temperature products.
The benefits compared to foam brick?
I think the biggest benefit when you compare it directly to a foam brick that's in PCM is going to be the fact that it's solid for physical performance. Is that if something happens to it, you don't have to worry about anything getting out of that packaging. I think the other thing, we start looking at foam bricks, the way that PCM is held in the brick itself, after multiple freeze-thaw cycles, you can actually have the PCM kind of fall out of the brick. It's kind of like, it doesn't actually maintain distribution throughout that brick evenly. So there are some other issues if you wanted to try to use that in a reuse application as well. So we intentionally looked at before we ever had gel PCM and we went to our liquid matte manufacturing process, we evaluated bricks as an option. We chose to go a different route for particular reasons, and now we've gone to the next step with gel PCM. So.
Can I feel the plain gel that you cut out of the bag?
Absolutely.
Put it in the cabinet.
Does it crumble or anything?
No. It's like a big chunk of Jell-O. So you could cut that in half. You'd have two chunks of PCM. This was a huge engineering challenge, and credit to our R&D team and advanced engineering team for pulling it off.